In a composition aggregation, an entity exclusively owns the other in composition aggregation in UML and data modeling. Nation-independent entities typically have clearly distinguishable names because they occur so frequently in the client's world. In addition, they usually have a single identifier such as stock code or nation code. Independent entities are often connected to other independent entities in a 1M or MM relationship. The data model in the following figure shows two independent entities linked in a 1M relationship. Nation and stock independent entities. Nation code, nation name, exchange rate, stock code, stock name, stock price, stock quantity, stock dividend, stock P, weak or dependent entity. A weak entity, also known as a dependent entity, relies on another entity for its existence and and identification. It is recognized by a plus on the weak entities end of the relationships. A city cannot exist without region. A city is uniquely identified by city name and reg name. If the composite identifier becomes unwieldy, creating an arbitrary identifier, easy citiano will exchange the weak entity into an independent one. City a weak entity. Region, reg name, reg type, reg top, reg area. City name, city spot, city area. Associative entity. Associative entities are byproducts of MM relationship. They are typically found between independent entities. Associative entities sometimes have obvious names because they occur in the real world. For instance, the associative entity for the relationship between department and employee is usually called position. If The associative entity does not have a common name. The two entity names area generally hyphenated is department, employee, always search for the appropriate appropriate name because it will improve the quality of the data model. Hyphenated names are a lost result. Position is an associative entity. Division, department, div name, department name, position, bus, backdate, ended, post title, post title, employee, emped. Associative entities can show either the current or the historic relationship between two entities. If an associative entities only identifiers are two relate, related entities identifiers, then it records the current relationship between the entities. If the associative entity has some time measure, e.g., date or hour, as a partial identifier, then it records the history of the relationship. Whenever you find an associative entity, ask the client whether the history of the relationship should be recorded. Creating a single arbitrary identifier for an associative entity will change it to an independent one. This is likely to happen if the associative entity becomes central to an application For example, is a personal department does a lot of work with position. It may find it more expedient to give it a separate identifier, e.g., position number. Aggregate entity. An aggregate entity is created when several different entities have similar attributes that are distinguished by a preceding or following modifier to keep their names unique. For example, because components of an address might occur in several entities, e.g., customer and supplier. An aggregate address entity can be created to store details of all address. Aggregate entities unusually become independent entities. In this case, we should use address number to identify an instance of address uniquely. Subordinate entity. A subordinate entity stores data about an entity that can vary among instances. A subordinate entity is useful when an entity consists of mutually exclusive classes that have different description. The farm animal database shown in the following figure indicates that the farmer requires different data for sheep and horses. Notice that each of the subordinate subordinate entities is identified by the related entities identifier. You could avoid subordinate entities by placing all the attributes in animal, but then you make it incumbent on the client to remember which attributes apply to horse attributes apply to horses and which to sheep. 23:13 to 23:13 to 23 over the 23. This becomes an important issue for null fields. For example, is the attribute high consumption null because it does not apply to sheep, or is it null because the value is unknown? Sheep and horse are subordinate entities. Dipped M, dipped name, dipped floor, dipped phone. Department's boss by imp no, imp frame, imp salary. Earlier, when deciding where to store the foreign key for the 1:1 relationship, we can settle on placing the foreign key and debt because all debt departments have a boss. Now we have a rule. The foreign key goes with the entity for which the relationship is mandatory. When specifying the create statements, you will need to be aware of the chicken and egg connection between debt and EMP both. We cannot insert a employee in the EMP unless we know that person's department, and we cannot insert a department unless we have already inserted the boss for the department in EMP. We can get around this problem by using a deferrable foreign key constraint, but at this point we don't know enough about transaction processing to discuss this approach. Let's now consider recursive relationships. The following figure shows a recursive 1M between employees, representing that one employee can be the boss of many other employees and a person has one boss. It optional that a person is a boss. And optional that everyone has a boss, mainly because there has to be one person who is the boss of everyone. However, we can get around this one exception by inserting employees in a particular order by inserting the biggest boss first. We effectively make it mandatory that all employees have a boss. Nevertheless, data models cover every situation and exceptions. So we still show the relationship as optional. 1M recursive with modality. Department, department floor, department phone, department's boss, EMP, EMP no, EMP name, EMP salary, employees boss. We really again on the British monarchy, this time we use to it illustrate modality with a 1:1 recursive relationship as the following figure shows. It is optional for a monarch to have a successor. We are not talking about the end of monarchy, but rather how we address the data modeling issue of not knowing who success in current monarchs. Similarly, there must be a monarch who did not success someone, i.e., the first king or queen. Thus, both ends of the succession relationship have optional modality. 1:1 recursive with modality. Succession. Monarchs, monarch's type, monarch's name, monarch's number, region, begin date. Finally, in our exploration of modality, we examine the recursive. The model indicates that it is optional for a product to have components and optional of a product to be a component in other products. However, every assembly must have associated products. Recursive with modality. Product, product, product broadcast, product price, assembly, quantity. Summary. Modality adds additional information to a data model, and once you have grasped the, the fundamental ideas of entities and relationships, it is quite straightforward to consider whether a relationship is optional or mandatory. When a relationship is mandatory, you need to consider what constraints you can add to a table definition to enforce the relationship. As we have in seen some cases, the foreign key constraint handles mandatory relationships. In other cases, the logic for enforcing a requirement will be built into the application.